exercise a little bit harder this time. We've got a couple new symbols here. This is the 3 is on the root symbol. This is not a square root. This is a cube root. And a cube root, for example, the cube root of 8 is 2, because 2 times 2 times 2, that is 3 factors of 2, produce an 8. And so the one is the 4th root, and let's do 4th root of, say, 16. We have to pick something other than 8, as there aren't 4 nice factors of 8. Instead, 16, 2 times 2 times 2 times 2, 4 factors, that's what the 4 is representing, of 2 makes 16. So the 4th root of 16 is the number 2. Now, these are different, and then we have this x over here that's just by itself. So we're going to use the same concept we learned up here. The square root, if there was a number here, it would be a 2. But this one is so commonly used that the 2 is always left out of the symbol. However, if it's any other sized root, you do have to put a number up here, right in this spot, to indicate the size of the root. Now, the 3rd root, we talked about the square root being 1/2 as an exponent, and what this means is if you took the, well, I think it's probably best if I write 5x, and then the 3 up here, the cube root, is the 1/3 power. And then the 4th root is the 1/4 power. Now be careful to put parentheses around this, because if you write it like this, that is a different thing. Those mean different in math. The parentheses make a difference here. What this suggests is that the exponent is only acting on the x, but we can see here, well, that's not the case. The exponent should be acting on both the 5 and the x, therefore a group is necessary. So don't do this. Okay, and then we have x to the 1st power. Now, like before, we can distribute the exponent here, and that's okay to do when there's no addition or subtraction in this problem, which there is not. This is all multiplying. And so this would read 5 to the 1/3, x to the 1/3, 5 to the 1/4, x to the 1/4, x to the 1st. Okay, and ignore my scribbles. Now, it's all getting multiplied, so it's okay to rearrange the multiplication so it's better to see. And oftentimes, you might just do this in your head to be able to see this. I will write it out for you to learn a little better. 1/3, 1/4. Okay, so now the 5s are lined up together and the x's are together. And when you multiply things like this with the same base, the rule is that we have to add the exponents. So we can make this 5 to the exponent of whatever this is when you add. So let's go ahead and do that. 1/3 plus 1/4 requires a common denominator. In order to add that, that would be equivalent to 4/12, because that's same proportion. 1/3 plus 3/12. And now, since we have the same size fraction, i.e. 12ths, we can add the fractions together. So if we have 4/12 and plus 3/12, that sums to 7/12. Some fraction addition for you. Okay, as bad as it looks, that is the exponent on the 5. And then it would be the same here, except we're adding this extra 1. Okay, so rather than this was 4/12, this was 3/12, and this would be 12/12. That would be equivalent to 1. And then, like before, we just add across the numerators. It's 19/12. Can't reduce that at all. So we'd multiply this x to the 19/12. Again, looks terrible, but there you have it. That is the skill to be practiced here.